Hey everyone, and welcome back to That Engineering Girl. Today we're going to be talking about my experience designing my first ever power supply, how I actually went through designing an actual power supply, like what steps did I take, what are my thoughts on designing it as a beginner, and if I would ever do it again. Like, is power supply something that I'm interested in? Well, we'll find out. Anywho, without further ado, let's get into it. Alright, so the first thing that I did is figure out my requirements. So what are my inputs, what are my outputs, and what do they need from me as a module? So when I say me, I'm kind of thinking about myself as the power supply now, so the power supply unit. So when I talked to the hardware lead, the documentation lead, who's also taking care of the actual integration, implementation, as well as the software lead and tech architecture, so those are the main roles that we have on my team this semester for my design project. When I spoke with them, they gave me all kinds of requirements. For example, the input voltage to the power supply is going to range from 7 to 10 volts, and the power supply needs to be able to manage that type of battery capacity. So that's an example of a requirement. Another requirement was the FPGA that we would be hooking up to the output. So the implementation / doc lead let me know that, hey, we're going to be hooking up the FPGA at the output, and it can at max take 5 volts plus or minus, and this is because the FPGA is very, very sensitive, and if we give it more volts, then it's going to combust. Essentially, it's just going to blow up in our faces. So that's another example of a requirement. We're also hooking up the ESC, so the electronic speed controller, for the motors, for the actual car, and then we were also hooking up an AM receiver. So the output voltage would be 5 volts, and then together combined we were designing for 10 amps. And these are the requirements that I gathered first and foremost. Next, so the implementation lead actually mentioned that we need over voltage, over current, and low voltage protection for the battery and the module itself. And so these are terms that I wasn't familiar with. So first of all, what I did is I researched into them, and then I connected with our tech architecture to understand how we would actually go about implementing these. Are these modules that we should just buy off the market? Because that just makes more sense, and it would be unwise to just go and reinvent the wheel per se. Or is it something that we actually are typically designing ourselves, and this is something that I needed to design? So after having that conversation with him, I realized that over voltage and over current protection is usually built into power supplies, so we didn't really need to worry about that. And so more specifically, the DC to DC converter, it's typically built into those modules or what's the right word? Or chips? I don't think that's the right word. And I don't want to say modules because that's like block diagram description of the power supply. Maybe chip. I'm not sure. Anywho, my point is, after speaking with a tech architect, I realized that I didn't actually need to design for the overcurrent or over voltage protection, but we did need to take into consideration the low voltage protection that we needed. So initially our plan was to actually design a low voltage cutoff circuit, which would automatically cut off the connection between the battery and the power supply if the battery voltage went below 7 volts. So FYI, the battery we were using was rated for 8.4 volts, and it was a 7-cell nickel something type of battery. I don't remember the exact chemical composition of the battery, but it was 8.4 volts, and we wanted to protect it from going below 7 volts in order to preserve the life of the battery itself. So that was another one of the requirements that I received. And building off of that, another requirement that we had to definitely consider is thermal management. So if the power supply itself couldn't handle the amount of current and power that we were asking it to deliver to us, we would need to install our own thermal management system. So whether that be a heat sink or fans or whatever it may be. So that was another consideration that I had to make when designing this. So at this point, I began exploring all my options for the DC to DC converter on DigiKey, Mouser I think it's called, and a bunch of different websites, and this was by far the most difficult part because the amount of search results that you get on DigiKey and the amount of filtering that's available is seriously overwhelming. Like, as a beginner, it's seriously overwhelming to see that many filter options, and like 6,000 search results show up, and you can order any of them that you want to, and all of them have data sheets and all that. So data sheets are fine, that's on a general scale easy to understand, but when it comes to power supplies and all of that jazz, then it's like, okay, I need to actually look at the specs, like what currents can it handle. When you start pushing the current threshold, when do you need to start adding your own thermal management, such as that. So those are the key pieces of information that I had to look through for the data sheets themselves. But alas, I digress. My point is, this was by far the most time-consuming part of actually designing the power supply, is figuring out a good DC to DC converter. Now, I picked a converter after a lot of searching that I thought would meet most of our specifications, if not all, and I actually connected with the tech architect on this, and he bounced back some ideas off of me. And we actually ended up deciding to order a power supply off of Amazon instead. And one of the concerns with this was actually because it's Amazon, and do you really want to be ordering electronic parts off of Amazon? But we alas took that risk, because one of the major benefits of that is we wouldn't have to worry about thermal management or any of the protection circuitry that a normal power supply would need. And this is okay with us because we're not actually creating a project that's power focused. If it was, then we would probably most definitely want to design this stuff ourselves. But because our project is more electronics based and more hardware based, then actually designing our own power supply from scratch didn't make sense. So we actually ended up ordering a quote-unquote power supply, and why I say quote-unquote is because it's actually just a DC-DC converter with thermal management and everything like that already built in, and the outputs, inputs, everything is already set up for us on its own custom PCB. So we actually ended up ordering that instead in the favor of time, because we were really stamped for time and we really needed to conserve our time. Now at this point I also picked a low voltage cutoff switch, but the problem with this was that it was generally built for only 1 or 2 cells, and that made no sense to me first initially, because lithium ion cells are more so between 1 and 3, I believe, if I recall that correctly. But this was a new concept to me, so I actually connected with the tech architect on this again, and he said, hey, this is probably not a good alarm for us for these following reasons. And once I understood that, I actually started looking at, okay, what's another solution for us? Because it seemed like the low voltage cutoff circuit, we couldn't just buy it off of the market, and we also couldn't afford to spend the time to design it. So that was our main conflict, so we don't have the time to design it, but we also don't have any viable options on the market. And this is where the idea of the low voltage alarm came from. So while I was researching on the internet, I actually came across this really old forum like 8 years ago that mentioned a low voltage alarm instead of a low voltage cutoff circuit. That when your battery reached a certain voltage, the alarm would just go off at like an ear-piercing volume, and then you would be alerted if your battery is low and you need to charge it up and unhook it from the actual system. So after bouncing this off of the implementation lead and the tech architect, we actually ended up with going with the low voltage alarm because it just made more sense in terms of scheduling and our design constraints and our design requirements. So we switched out the low voltage cutoff circuit with the low voltage alarm, and that was actually better because we could actually offload the alarm to another part of the car without having to need it on the PCB, which is, I'm gonna make a whole other video on what I'm referring to, but essentially all of this, so the power supply and its connections to the ESC in particular, because we were actually designing the ESC, we're gonna be on a custom PCB that I actually designed. So I'll actually create another video on that, but that's just a little overview on what we actually did with this at the end. Now at this point we had to do some creative designing, quote unquote speaking, because it wasn't a lot, but it was fun because the low voltage alarm that we could find anywhere really on the internet were designed for lithium ion batteries, which was not the battery that we were using. And so after spending a lot of time researching and trying to find something anywhere in the world that would work for us, I realized, hey, we can actually get this to work for us. So I connected with the implementation lead and we bounced off ideas off of each other, where we eventually came up with the idea of actually treating the battery itself, which technically has 7 cells, as a 1-cell battery, because the low voltage alarm for a LiPo battery can only handle, I think, up to, actually it's up to like 8 cells, I think, but the difference between a LiPo and the battery that we were using is that we didn't have access to the individual cells in the battery, so we couldn't actually measure the individual voltages of each cell. which is how the alarm I think actually worked, if I recall correctly. So we actually decided to interface it with the alarm, showing it from the alarm perspective as a 1-cell battery. But then we also had to take into consideration that in order to get the alarm to work, it needed to be interfaced with at least 2 cells. So it needed to have, I believe it was 3 pins used up to the 2nd cell pin. So then what we decided to do is actually short 1 or 2, the 1st cell and the 2nd cell leads together. So technically we're using all 3 pins, but we're really just showing it 1 voltage rather than 2 different voltages. In addition to that, what we also did is we had to interface the alarm with a voltage divider between the battery, because for the battery, we wanted the alarm to go off at about 7 volts, whereas the alarm, its highest alarm voltage was 3.5 volts. So we need to deal with that. So obviously in any problem in electrical engineering, the first thing that you do is you go to your voltage divider, because they are our good old voltage dividers, and that's exactly what we did. So, and why I say good old voltage dividers is because they solve the majority of all of our problems. Like seriously, like just bless their souls. But anywho, we decided to add a voltage divider between the battery and the alarm itself. So when the battery was at 7 volts, the resistor that was actually seen by the alarm in the voltage divider configuration was actually 3.5 volts that we set it to. So we actually got the low voltage alarm for the LiPo battery to work for our battery, which was completely off the specs for the actual alarm. So that's why I say it was creative designing. Now at this part, I thought the design was pretty much done. I was really proud of myself. But then after reading the specs more carefully for the buck converter that we chose to use, so the DC to DC converter that I was referring to previously, it actually could only handle, I think, about 6 to 8 amps, around there somewhere, without additional thermal management. But we were actually designing our system for 10 amps. So I reached out to our tech architect again, and when I connected with him on this, he said, you know what, hey Ruha, yes, we could add extra thermal management and that would solve our problem, but it's so much easier for us to just choose a different buck converter because there's so many readily available. So literally in 5 minutes while I was searching, he literally sent me another buck converter that was the same, but it had a 20 amp rating. So it was way above our requirements and our specs that we needed, so it would definitely work for us. And once again, in the interest of time, because we were really strapped for time, we decided to go with this, although I'm sure if we searched somewhere, I'm sure if we spent more time, we would have found some sort of compromise between, you know, overshooting our design specs so much that although we only need 10 amps, we're designing for 20 amps, we could have definitely found some sort of compromise there. But alas, we were strapped for time and we just needed to get this thing done. So we chose a different buck converter, and finally the power supply design was complete. Now, what are my thoughts? You know, going through this entire process for the first time, especially related to power, because I've never done anything power related before, what are my thoughts? Well, from a general level, I thought it was a really good experience. Like, honestly, it was such a great experience because I'm not familiar with power at all. It gave me the chance to actually learn something new rather than just regurgitate and reiterate and build on what I already know. So it was nice to build some sort of level ground on an area that I hadn't actually touched before. So that was great. Overall, I would say I learned a lot about power supply design and power supplies in general and converters, and how do we actually power our projects, for example, our hobby projects. How do we actually power them without our laptop and all of that? So it was a really great experience, I would say. Now, would I do this again? This first experience, definitely, because like I said, I got to learn a lot. Would I do it again just because I absolutely love power and everything related to power? Highly unlikely. Because although I want to have a broad spectrum of skills, I don't want to deep dive into skills that I don't enjoy developing. So on a high level, yes, this experience was awesome, but I myself in particular am not very interested in power, and so it doesn't make sense for me to explore that skill and that subject if I'm not interested in it, at least at my current state. So right now, highly unlikely that I would actually do this again, like as a repeat and build upon this experience to gain more skills. but this first experience definitely to get that basic foundation in. And those are my thoughts on how I designed a power supply and would I ever do it again. So I hope you enjoyed listening to me talk, and I hope this helps you, and I hope you actually decide to explore this, because like I said, it's always great to have a broad range of skills. With that, I'll see you next week.